Velocity is the rate of change of the displacement of an object with respect to time. If if S is the displacement, then V is equal to ds by dt, right? The rate of change of displacement with respect to time. The graph to the right shows the displacement function of an object. What is the initial velocity of the object, or the velocity at time 0? Okay? Equals 0. What can you say about the velocity between A and C? It's constant, right? So if the rate of change, if it's a straight line, right, then the rate of change. So it's constant. And what else about it? It's constant and increasing or positive, right? So it's constant and positive, right? It has a positive slope. So constant and positive. What about between C and D? It's 0, right? If there's no change in displacement, then there is a 0 velocity. So the velocity is 0. How do we know? It's a horizontal line, right? Was the object moving faster at B or at E? And justify your answer. So faster at B or faster at E? E. Why? Yeah, slope of the tangent line at E is greater than the slope of the tangent line at B. So moving faster at E. Right, and the justification. Okay, gonna grade yourself. What is the velocity at F? 0. What is the object doing at F? Changing direction, right? So it's momentarily at rest while it changes direction. Right? We've gone to there, and now we're okay. So the velocity at F, so V is equal to 0. The object is changing direction. What can be said about the velocity at G? It's negative. And what else? It's greater than what? Yeah, it's the fastest speed on there, right? Yeah, it's got the greatest of any of these lines. It has the greatest slope, so it's the largest in magnitude. Okay, so it's negative and larger in magnitude than any other velocity. What does the magnitude have the velocity, or what's the magnitude of what's just the magnitude? It's just the speed, right? It's just the size of the velocity, right? It's how big. We don't care about the direction at this point, right? So here, well, we've said it's negative and it's larger in magnitude than any other. How does the speed of the object at G compare to the speed of the object at E? Greater. Okay. Because yeah, speed. So the speed is greater at G because yeah, slope is steeper, so the magnitude is greater, right? So it's greater because the slope it is greater. It is greater because because the line is steeper. And what can we say about that? I mean, the absolute value of the slope is larger, right? So we're comparing speed. We're really interested in the absolute value of the slope, right? So the absolute value. And taking the absolute value is just going to give us the magnitude, right? Magnitude of the size, right? We don't care about the direction, so we're interested in speed. The height of an object is given by h of t is negative 5t squared plus 30t plus 15, where h is in meter and t is in seconds. Determine the velocity of the object at 2 seconds. So how do we get velocity from height? Sorry, what? Derive it. Yeah, so what is height? Height is really displacement, right? It's a change in position. What's velocity? The rate of change, right? So we could say that v of t is equal to h prime of t, which is equal to, so what's h prime of t? Get the signs right. Oh, sorry, did you say negative? Didn't hear the negative. Right, negative 10t.
Yes, I did say negative.
I didn't hear the negative the first time. Right? Aha.
The one time someone didn't hear me.
Ah, no, it's two someones. Whatever. Negative 10t plus 30. Okay, so what is the velocity at 2 seconds then? So v of 2 is negative 10 times 2 plus 30, which is
Goodbye. Please.
10 units, meters per second. And there is a direction on that, right? It's positive 10. Okay, so it's going up based on a frame of reference, I believe, right? Because gravity is, negative 1/2. You did all the physics stuff, right? So negative 5 is half of negative, or it should be negative 4.9, right? Like negative 9.8 meters per second. Don't worry about it. We just round. Because you can't use a calculator. Oh, sorry, you may not use a calculator. It's not that you can't. Determine when the object reaches its maximum height. So it reaches its maximum height when what happens? So what's its velocity when it reaches its maximum height?
Velocity.
0, right? So it's going up, and then it stops. When it stops, it's no longer going up. We're looking for the max. Yeah, this is what this unit's all about, right? It's like max min. All right, so what do we need to find? So the maximum height occurs when v equals 0. So let's write this down, right? So the maximum height occurs. I can never spell occurs. What is it, 2 C's? Occurs when the velocity is 0. All right, so we know that the velocity is the change in height. We have an expression for that, right? So we want 0 is equal to negative 10t plus 30. So what's t? I mean, we do a little bit of work, I suppose, right? Negative 30 is equal to negative 10t. So t is 3. So the maximum height occurs. Now, does it, and then it says, and then determine its maximum height. So how are we going to find its maximum height? Yeah, substitute 3 into h of t. So here we could just say it reaches its maximum height. Reaches its maximum height. I never know when to use apostrophe. Yeah, maximum height. When t is equal to 3. So we have h of t is negative 5t squared plus 30t plus 15. Let me figure out. It's worth having a partner for no other reason than to check your arithmetic, right? Like you'd be working out, the max value of whatever at whatever, and it's like, it's a sine of pi over 6, and between the two of you, somebody should know the sine of pi over 6. So h of 3 plus 30. All right, so what do we got? Negative 45 plus 90, which is 45 plus 15. So 60? Okay, so what do we have? What are we going to say? The object reaches a maximum height of 60 meters at 3 seconds, right? I mean, that nails it all down. So the object reaches its maximum height of 60 meters at 3 seconds. All right, we got nice units in there and everything. Determine the velocity of the object when it hits the ground. Okay, when does it hit the ground? When its height is 0, right? So we got to figure out, okay, when is its height 0? So we've got h of t, so terminal velocity. So it hits the ground. When its height is 0. Okay, so 0 is equal to, well, let's do it the other way around. Negative 5t squared, what was it, plus 30t plus 15 is equal to 0. All right, what do you want to do? Well, we're just going to solve that, right? So let's do what? Divide out the negative 5, right? I mean, come on, everything's divisible. Now, just remember, when you're working out the first derivative, you want to factor out the negative, but you have to keep the negative with it, right? Otherwise, you'll have things increasing when they're decreasing. We're just working this out to be 0, then it doesn't, excuse me, it doesn't matter, except if I'm dividing, so minus 3 equals 0. And of course, it doesn't factor, right?
Oh,
All right, so what's the formula quadraticus, the quadratic formula, right?
I don't remember. Negative.
Yeah, you do. You never sing it to the tune of Pop Goes the Weasel?
No.
It's on the formula sheet.
Yeah, it's on the, I know that, but x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Really?
What is Buffalo's Louisiana? I think I'm dropping calculus just for that. Throw away my future gladly.
Another one bites the dust. Minus 4 times 1 times negative 3 over 2 times 1. All right, what do we got? 6 plus or minus, so we got what? 36 plus 12, which is what? 48? That doesn't need to be so big. Over 2. 6 plus or minus 4 root 3 over 2, so 3 plus or minus 2 root 3. All right, so what is the time when it hits the ground? So it hits the ground. Yeah, it's the positive one, right? So t equals 3 plus 2 root 3. Seconds. Okay, is that it? We're done? We just needed to figure that out? Lunch will be efficient, right? Since you...
Oh no, the fish died.
So it was a while back. So is that it? We done? No, that was the preliminaries, right? It was just figuring out when. What do we want? We want the velocity. What's our expression for velocity? Negative 10t plus 30, was it? Yeah? Okay, so v at 3 plus 2 root 3 is negative 10 times 3 plus 2 root 3 plus 30, which is what? Negative 20 root 3, right? I mean, that's going to be negative 30, so those are gone. So it's just negative 20 root 3 meters per second. So when it hits the ground, it's going negative 20. It's a good thing it's negative because it's got to be going down, right? 20 root 3. Yeah, whatever that is. Okay. You good? Ready to move on? No? Still copying things down? All right. I'll let you continue to copy things down. Almost done, right? What do we got? Oh, no, wait, there's two more. One more with like 4 parts.
Holy fuck, that's so many parts.
Yeah.
How is this
Which
shit?
reminded, I've got some avocados going bad in the fridge at home right now.
No.
The position of an object is given by S of t is 2t cubed minus 21t squared plus 60t, where s is a meter and t is a seconds. Determine when the object is at rest. When is the object at rest? When the velocity is 0. How do we get the velocity? Derive. Okay. So the object is at rest when the velocity is 0. The velocity v of t is equal to s prime of t, which is okay, so then what are we going to do with this? We're going to set it equal to 0. And we're going to hope that this one factors. So t squared minus, that was a 42, minus 7t plus 10. Okay, so that does. Okay, so the object is at rest when?
2 and 5.
Yeah, at t equals 2 seconds. So at 2 seconds and at 5 seconds. At 2 seconds. So I mean, you know, we can just. Okay, at 2 seconds and at 5 seconds. And its displacement is a cubic, so it's moving around, right? It's kind of going away and then coming back and then going away, or yeah, it's a positive cubic, right? So, but we're going to start at time t0, right? But we're not really too worried about this. Determine when the object is moving in a positive direction. So what do we need for the object to be moving in a positive direction?
You do like the derivative type.
Yeah, you do the derivative, right? And what do we want? We want when the velocity is greater than 0, right? And then that means that the displacement, right? If the first derivative is greater than 0, then the displacement is increasing, right? If the first derivative is less than 0, then the displacement, that makes sense, right? I mean, the velocity is positive, then you're moving away. And if the velocity is negative, then you're moving forward. So we need and we have the velocity, right? Except what we need kind of is the factored form. So here, let's throw a little 6 in front of that. And let's throw a 6 in front of that. Right, so we keep the thing, right? Even though the 6 is always positive. I mean, it's not so important here. It's like if you forgot the 6, so what? It's not going to change anything. But if that's a negative and you forget this, then everything changes, right? All of a sudden, you're going to say it's increasing and it's really decreasing. Okay, so what do we want to do? Well, we want to say, okay, got 0, I got 2, and I got 5. And I got a 6, which is always positive. And I've got a t minus 2, and I got a t minus 5. And if I take those all together, I'm going to get a velocity, so v of t, which is going to tell me something about the displacement, which is s of t. Okay, so 6 is always positive. T minus 2. So we've got a number in here like 1. 1 minus 2 is negative. You got a number in here like 4 minus 2 is a positive. Positive, and t minus 5. And if I subtract 5, and so what do we got? Increasing, decreasing, increasing. So when is it moving in a positive direction? When its displacement is increasing. Okay, so moving in a positive direction. Positive direction when the displacement s of t is increasing.
It was never not increasing.
Okay, so that is on the interval 0 to 2, and where else? 5 to infinity.
How is it moving in a positive direction forever? I thought perpetual motion machines weren't a thing.
It's not, but time, it just goes on until the end of time.
Well, but that is perpetual motion, is it not?
Mm-mm.
Well, they're not taking a pause to like
Okay,
fuel up
okay,
or something.
but if it was in space and it just got a nudge, then it's just gonna go, right?
There's never eventually stop.
Well, yeah, it would be affected by gravitational forces and that, right? But that's how they get the, you want to go to Jupiter, you fling the thing around Mars, right? Because you get that gravitational boost, right? So you don't just try and, hey, let's fly from here directly to Jupiter. That's gonna take a long time, right? But you slingshot it around Mars.
What about when the universe ends?
You don't have to worry about it.
Well, but it's still not infinity.
Did you ever read that? There's an Isaac Asimov short story. It's The Last Question or something. You should read it. It's short. Use the table of values below to draw a diagram to illustrate the motion of the object. So, all right, we want to illustrate the motion of the object. Then, what we can think is it's just moving along this straight line, right? So we've got 0, 0, and at time 1, it's at 41. Okay, so it's going to move to there, and at time 2, it's at 52, and then it comes back to 45. So we're going to kind of say, all right, so it's moving along like this, and then at time 3, it's at 45. Okay, so it's there. So this is what? T equals 1. This is T equals 2. This would be T equals 3. So we come back to 45, and then at T equals 4, we're at 32. So that's T equals 4. And at T equals 5, we're at 25. So there's T equals 5. And then T equals 6, we're at 36. So we turn around, so here. T equals 6, and at T equals 7, we're at 77. So that's T equals 7 is off there, right? So we'd say we're increasing displacement to time equals 2, and then decreasing displacement, right? And then increasing displacement. Just the information that we saw from the first derivative, right? Telling us what the velocity was, which then tells us what the displacement. Determine the total distance traveled during the first 6 seconds. So the total distance, right? Not displacement, right? Displacement in 6 seconds is 36. Whatever. I don't even know what units this is in. Is it? Yeah, I know. Is it units? There are units on this, right? What is it? Meters?
Yeah.
Yeah, okay, meters.
Yeah, this is the top of example 3.
Okay, there we go. So it's meters, right? So the distance is going to be, well, I mean, really, we could just worry about this, right? So we'll say it's what distance am I moving, right? So it's S2 minus S0. And we're going to do this as absolute value, right? Because distance is the magnitude of the displacement, right? The size of it, it's not the direction. Okay, because some are positive and some are negative, right? And then there's a negative, so what happens? Well, we're interested in from 2 to 5, so what's S5 minus S2? And then 6 seconds, so then what happens from 5 to 6? Okay, so we need to know these, right? I mean, I don't care about the distance from 0 to 1, because I know it's moving in a positive direction from 0 to 2. So we'll take that distance from 0 to 2, right? Which is what? So 52 minus 0 plus, and then we've got from 2 to 5, so it's moving backward. So this is going to be 20, excuse me, 5 minus 52. And then we've got from 5 to 6, which is 36 minus 25. Right? And since we want distance, it's the magnitude of the displacement, right? It's the size. So it's like you get a little odometer on this thing, right? An odometer doesn't care which way you're going. 25 to 52 is what? 27? So it'll be 27. And 11. So that's 38, 40, 90. So the total distance traveled is 90 meters. Right? Its displacement in 6 seconds is 36 meters. Or it's 36 meters from where it started, but it traveled excuse me, a distance of 90 meters. Okay, is that it?
Yeah.
Woohoo.